In this section of the probability unit, we are going to be learning about odds. Odds in favor of an event and odds against an event. Let's look at some examples using probability, the theoretical probability of an event. So in our first example, we're finding the probability of landing on a prime number if we're looking at this dial. And let's count the prime numbers together. Is 1 prime? No. Is 2? Yes. So 2, 3, 5, 7. So that's 1, 2, 3, 4 are going to be prime out of how many? Well, there's 10 here, right? So if we simplify, what does that equal? 2/5. So then what's the probability of not landing on a prime? Well, we could count them up, or we could keep it real simple, right? We could say, well, if there's 4 that are prime and there's 10 total, then how many must not be prime? 10 minus 4, which is 6. So 6/10 will not be prime. We can double check. 1 is not prime, 4 is not prime, 6 is not prime, 8, 9, and 10 are not prime. 1, 2, 3, 4, 5, 6. So what does 6/10 equal? It equals 3/5, right? So the odds in favor of landing on a prime would be the number that are prime. So let's look back at our probability examples. How many are prime? 4, right? Out of, or compared to, the number that are not prime. So how many did we figure out are not prime? 6. Now we're going to write this with a colon instead of as a fraction. Odds are typically written with a colon. We know that when we're talking about ratios, we could write them as a fraction like we do with probability, with a colon like we do with odds, or we could also write it with words. So we're going to simplify 4 to 6. And what would you get? 2 to 3. So for every 2 places on this dial, we could have a prime number compared to every 3, which would be not prime. So odds against landing on a prime is our next problem. So odds against landing on a prime would be odds in favor of not landing on a prime, right? So what's the probability of not landing on a prime? We found that up here, right? 6. So 6 of these are not prime. So this is basically the same as not prime. Odds against is the same as not prime. And then we want to say 6, which are not prime, out of the compared to the number that will add up to equal the total. What was our total? 10. And so 6 compared to what? Knowing that 6 plus whatever this is will add up to equal 10. 4. So simplify, what do you get? 3 to 2. So the trick with odds is that the two numbers add up to equal the total number of options. So in this case, we had 10 options, or 10 places we could land on. So 6 and 4 equal 10. Here are the formulas for dealing with odds. So the odds in favor of an event would be the probability of the event occurring. So let's say we use our example that we just did, odds for landing on a prime. So the probability of landing on a prime was 4. And 1 minus the probability of the event occurring. So in other words, the total minus the probability of the event occurring. 1 would represent the whole, so you could think of it as a 40% chance that the probability would occur. 1 would be a 100% chance minus the 40% chance would give us a 60% chance for the denominator, and we saw that as 4 over 6, and we wrote it as 4 to 6. We could also think about probability as a decimal as well as a percent. So let's use that as our example with odds against. So let's say here that we know the odds against landing on a prime. We know that that was 6 to 4. So let's think through with our formula. 1 minus 0.6 would equal 0.4. So 0.6 plus 0.4 would equal 1 whole. So the basic thing you need to walk away understanding is that the probability plus not the probability gives you the total events. So the probability plus not the probability equals the total number of possible outcomes. So the probability plus not the probability happening equals the total number of outcomes. And we can see if we're focusing on odds in favor, we'll have odds in favor over odds against. And we know that odds in favor over odds against should give us the total number of outcomes. If we're looking for odds against, we have that over odds in favor, and again, those should add up to equal our total number of outcomes. Let's look at some more examples. So we want to find the probability of landing on one of these spaces that is both striped and even. So it has to be both of those. So let's look at our striped numbers and see if any of them are even. 7's not, 5's not, 3's not, but 2 is even. So we have 1 out of how many? 10, right? So what's the probability of not landing on one that's both striped and even? 9 out of 10, right? So now let's change these into thinking in terms of odds. So what's the odds in favor of both striped and even? So you're going to put the probability that they're both striped and even, which was 1, but we're going to compare that to how many are left to add up to our total number of outcomes. So that would be 1 to 9, and 1 plus 9 is 10. So that's important that 1 and 9 add up to the total number of outcomes. So now let's look at the odds against being striped and even. Well, what's the probability of not being striped and even? 9, right? Compared to how many are striped and even? 1. And again, those add up to 10. In this next example, we're looking at a table that has all the outcomes listed if you were to roll 2 6-sided dice. And what we're looking at is the sum of what the dice would give you. So for example, if I get 1 on my red die and 2 on my blue die, the sum is going to be 3. If I get 5 on my red die and 4 on my blue die, I come down to where they intersect, 9 is my sum. So that's how you read this table. The first question asks us to find the probability of getting a sum of 8. So just look at the table and highlight all your 8s. So this is what your table looks like when you highlight all your sums that are 8. So the probability of finding a sum of 8 is 5 out of 36. We know that there's 36 total because 6 times 6 is 36. So keep it simple with figuring out how many you have total. Let's look at the next problem. In the next problem, we're asked to find the probability that you don't get a sum of 8. So what's the easiest way to do that? Do you want to count in your table? Well, if you think you should find the total, which we already know is 36, and subtract how many equal a sum of 8, that is the easiest way to find the probability of not a sum of 8. Since there were 5 sums of 8, you would say 36 minus 5, and that gives you 31. So there's 31 outcomes that are not a sum of 8 out of 36 total. So now let's think in terms of odds. We want to know the odds in favor of a sum of 8. So give that a shot. You should have 5 to 31. Since there are 5 sums of 38 compared to 31 that are not the sum of 8, then you get 5 to 38. Try the next problem, odds against a sum of 8. You should have 31 to 5 because there's 31 that do not have a sum of 8 compared to 5 that do. And again, remember that the 5 and the 31 add up to equal 36 in both, which is the total number of possible outcomes. That's very important with odds. Next, we're dealing with a deck of cards. And to help you know how to break this down, you're told that there are 52 cards in a deck, 4 different suits. So that's, you can see 3 of the suits here: diamonds, spades, and clubs. We are missing hearts here. That would be your 4th suit. And there's 2 different colors. The hearts and the diamonds are red, and then the clubs and the spades are black. So now that we know this information, let's look at the first problem. It says the probability of getting a red face card. So let's talk about what face cards are as well. Face cards are any cards that have a face on them. So face cards are going to be kings, queens, and jacks. So you're asked, what is the probability of getting a red face card? So we have 3 face cards, and how many suits will be red? 2, right? So how many face cards do you think you would have? So altogether, a red face card, we're going to have king, queen, jack of hearts, king, queen, jack of diamonds. So that's 6. So the probability of getting a face card is going to be 6 total cards out of, and it tells us right here, 52 total cards. So go ahead and simplify that fraction. You should get 3 over 26. So the probability of getting a red face card is 3 over 26. So next we're going to find the odds in favor of getting a red face card. Give that one a shot. So the odds in favor of getting a red face card, well, we have 3 that are going to be red once we simplified out of 26, but we want to subtract 26 minus 3, so we get 3 to 23. Now try the odds against getting a red face card. You should end up with 23 to 3. Here's another example where we're rolling 2 dice and we have a table that shows the sums of the 2 dice. Our first question says, what's the probability of getting a prime sum? So we want to look at all the sums and find the ones that are prime. So go through and highlight all those. And this is what you get once you highlight all of them. How many primes do you have here? Prime sums do you have here out of your total? What's your probability? If you said 15 to 36, you're correct. And of course you will want to simplify that to 5/12. Next, determine the probability of not getting a sum that's prime. So 36 minus 15 is 21. You end up with 21 that are not prime out of 36, which you can simplify to 7/12. Next, determine the odds in favor of a prime sum. You should end up with 15 to 21, which is simplified to 5/7. And you can see that in our numerators here. Lastly, find the odds against a prime sum. This should be the reciprocal of the odds in favor. So instead of 5/7, you have 7/5. Finish the rest of this section as part of your homework.